All right, do we have any questions so far? I believe Ariana's not going to be here because she moved back home from the dorms and they don't have internet yet at their house.
How many tests are there going to be after this one?
After this one,
Like, are they just smaller units? Because, like,
it's just one more test after this one, I think.
the
And then
final,
no, there's one more chapter test and then a final.
is it just a shorter, like, less
Yeah,
stuff?
I think
Because
so. Yeah.
there's only like 3 weeks left.
Yeah,
So,
yeah. It's going to be so not that many sections in that chapter, I don't think. Let me see. When is the next one even? Doing there's 7 sections in it, I guess. So, in 2 weeks we could have it done and then we could kind of decide. And it's on things that a lot of people probably looked at before, exponential functions, log functions. And so, we talk about them, we graph them, then we talk about the next one, then we graph it, and then we talk about some properties and equations of them. So it's not a lot of complex stuff. So it should be pretty easy to get through. Any other questions?
So when is this test?
Thursday.
That's what I thought.
Yeah.
will it for sure only take 50 minutes this time and not 3.5 hours?
Well, I don't know because you took, what was it on average? About the average was about, what did I read on there? 20 some minutes for 5 questions, and that was 5 sections. Then we got 6, 7, 8. We got 6, 7, 8. Then 5 more sections after that. So probably another question or so out of each of those. And so it's going to be right around the hopefully an hour mark, unless for some reason some questions are harder for you than others. But hopefully it's not going to be quite as long as the last one. Plus, being in mom now, hopefully that'll be another issue that we don't have to worry about trying to figure out things in Moodle and doing all that. So hopefully doing everything in mom and doing the practice tests in there and stuff will help you kind of guide you on what kind of work to do there. So
How can we get like partial credit? Since it's in mom, it'll tell us if we got it right or wrong, but
mm-hmm.
generally it's like you're either 100% right or 100% wrong.
Yeah, so when you get done, take photos of all your stuff and try to put them in order, and then just send me that file.
Okay.
That way I can kind of see what is right or wrong, and where did you go wrong, and was it just a typo or what. So because some of them on that quiz there was some typos. It was, I think Ben had a typo or something. It was a, I don't know, a comma instead of a period or something like that, and so I gave him more points on that. So
Gotcha. Okay.
How are you doing, Barry?
better. So yeah, what happened was I didn't know what was going on with me after our class on Wednesday, and so all of a sudden I just had uncontrollable shakes and doing all kinds of weird stuff, and then I realized after, I don't know, almost a day, I was having a kidney stone passing. So, and then that just caused lingering effects and just wasn't up to anything for a few days. And today is actually the first day I feel better. I don't have headaches or anything. So
Oh my gosh, that sounds miserable.
yeah, it wasn't too much fun. That was my first one. So
Yeah, Corona sounds preferable.
yeah, well, maybe as long as you're the surviving corona.
Right.
All right, so what we're doing today is we're doing section 2.4 from the other book, so it was kind of the extra handout too, as far as chapter-wise goes. And it's dealing with inequalities with absolute value, as well as quadratic functions. And so what I have here is kind of some graphical interpretations of equations and inequalities. So we're going to have f and g be functions. And so in our first one over here, what we have, if I can figure out where I'm at here, what we have is the f of x equals g of x. We want to figure out where they're equal. Well, where they're equal is where they actually are intersecting. And so it intersects at this first piece right here, and it intersects over here. And so I kind of wrote in red, f of x equals g of x is where the answer is as far as what it is. And it's just that point here, and that point here is the solution. Now, if we want the solution of f of x less than g of x, that's a set of all x values where the graph of f of x is below the graph of g of x. And so if we look on the graph, you know, that's our g of x, this is our f of x. Well, f of x is less than g of x, kind of this red line here and over on this side. So that's where f of x is less than g of x. So basically it's from negative infinity to wherever that is here on the x, and then from wherever that is on the x to positive infinity. So it's going to be a union. Now, the solution to f of x greater than g of x, that's the set of all x values where f of x is above g of x. And so in that case, that's this everything up here. And so you're basically going from this point to this point, and that's going to be all f of x greater than g of x. So the nice thing is we can graph things and actually get a solution, and we can also work them out mathematically. So it works both ways. So let's look at one and where we have to graph, and it says basically graph the following two functions and determine where the solutions lie for the given question. So what we want to do is just kind of what we looked at. Where are they equal? Where is f of x less than g of x, and where is f of x greater than g of x? All right, so what we have to do is we have to graph. So we have to kind of remember how our functions work. So x squared, you know, that's going to be our parabola, and that's, you know, where it goes down the center and like that. That's the regular x squared. And then if we have x squared minus 2, well, then basically this is going to be going, well, nice curve there. Oh well, we'll just leave it for now because it doesn't matter too much. And so that's that. And when we have this one, first we take the negative x squared. Well, that's going to make it come down like this, but then we're going to move it up 2. So then it's going to come up 2. And so we have something like that. So these are points where it's going to be equal at this stage here and this stage here. So what we need to do now is figure out what are those points. Well, we can figure out what they are because what it's going to be is when that is equal to 0. So we have 0 equals x squared minus 2, or, you know, same thing here, 0 equals minus x squared plus 2, but it's going to end up being the same equation. And so then x squared is equal to 2, and we take the square root of both sides, and we want plus or minus here. And so x is equal to plus or minus the square root of 2. So here we have the point negative square root of 2, 0. And here we have the point square root of 2, 0. So that's where x is plus and minus square root of 2, basically. So f of x equals g of x. Well, for one, where are they equal? Well, they are equal where those points are intersecting. And so basically we just write down those points again. So negative square root of 2, 0, and square root of 2, 0. So that's where the two functions are equal. Now the second one says where is f of x less than g of x? So we probably better write this on which one is which before we forget. So this is going to be our f of x, and this is our g of x. So let's maybe change a color here so we can kind of, or maybe let's put a highlighter on, that might be even better. So we'll do yellow highlighter for this one. We'll remember this is the yellow one that way. So f of x is less than g of x. So where is f of x, which is this curve, less than g of x? Well, g of x is up, and so basically we're going to be less than here, kind of in this position here. Okay, because at this position g of x is less than f of x, and we're above the g of x here. But at this position, this is the only place we're actually less than. So now we can write that if we can get our marker to disappear, or the highlighter. There we go. All right, so we know it's going from basically here all the way to here, and so basically we can just say our solution, I guess it's a bracket, not a parenthesis. I better change that. So that's going to be a bracket from a negative square root of 2 all the way over here to the square root of 2 bracket. Okay. Now 3, if we change to a different color of highlighter, maybe they'll let us. How about we do green? And so green, what we want is f of x greater than our g of x. And so where is that? Well, f of x is larger than g of x along this piece and along that piece. Not quite straight there, but that's where it's going to be greater. And so we basically are going from negative infinity all the way up to this negative radical 2. And so we'll do negative infinity. Now in this case, because how it works, it's just going to be from negative radical 2. We're going to use parentheses and union. And then it's going to be parentheses again, then radical 2 to positive infinity. Okay. So when it's, you know, always going to be directly in like in this region, then you're going to have that bracket, and then the otherwise it's going to be that parenthesis. Okay. So now we found, you know, where they're equal, where one's the f of x is less than, and then where f of x is greater than. So that's our 3 things. And again, using our knowledge of transformations and what we do, we were easily able to draw those graphs and proceed from there.
Why is it a bracket on that one if it's not less than or equal to?
Yeah, and that's it's just because when you have one region being in the infinity, then you just go ahead and you keep the other one at the kind of the same kind of region, and then the other way.
I mean, for the second one.
Oh, second one. Why do you have brackets? Because it's you actually are going to have it at that point. It's yeah. They said but brackets, but I never understood it. That's why I started with parentheses, because I think it should be parentheses personally. But you know, maybe for test's sake, let's put it for parentheses, and then we don't have to worry about it. Because you know, like I said, I think personally it's going to be a parenthesis, because it's going to be like this over here. It's going all the way up to there, but it's not including that point, because that would be where it would be equal. Now, if this was, you know, saying that, then yeah, they were going to be brackets, but it should be technically just the parentheses based on, you know, without the things. But in one book I was reading, it showed brackets, and they had just a strictly less than, and they said, well, because it was in between, and that's how it would work. But personally, and like you're saying, why isn't it parentheses? Well, because here, if it's at that point, it should be a bracket if you have that less than, or well, I guess, yeah, that's less than or equal to. So if you had the less than or equal to, then it should be the bracket. But in this case, we don't have that, and so it should be parentheses. So I agree with this one more. It's just not how the book had stated it. And so let's go with this one, and then we won't actually have to worry on the test if we have something like that. We'll just agree with based on our original thing. You know, if you have less than or greater than, it's the parentheses, and if you have greater than or equal to or less than or equal to, then you have your brackets. How about that?
Works for me.
Works for me too. That's what I thought it should be, but they had it the other way, and I'm like, I don't know if I trust that, but if that's what they think. All right, so then if we have inequalities that involve absolute values, so that's really kind of the key what this section is going to be about. But we're going to let C be any real number. So for C that's greater than 0, and then if we have the absolute value of x less than C, then we can rewrite that as minus C less than x less than C. And so basically we're being able to rewrite this absolute value, drop the absolute value, and we put it into this form here, and then we solve. So whatever's inside of the absolute value might not just be x, it might be 2x plus 5 or 2x minus 5 or whatever. You plug that in here, and then you start solving out until you get just x, and then you'll know where your x region is. And this is for C greater than 0. Also for C greater than 0, if it's less than or equal to, then you just change it to less than or equal to signs. Now, if c is less than or equal to 0, then basically we have a nice thing, because absolute value of x less than c, well, that's not going to be a possibility, because if we have a negative number here, absolute value can't be less than a negative, so there's no solution. And same thing here, even if you have the less than or equal to, it's still not going to be a solution if your c is negative. So that's the ideal situation when you don't actually have to do anything. Now, c greater than or equal to 0, we got two possibilities, the greater than or equal to. And basically what we have is we're going to have x is less than or equal to, and somehow the negative disappeared here, but that's okay. And so it's less than or equal to negative c, or x is greater than or equal to positive c. Now remember, when you have something like this is and these are our ors. And then we also have c less than 0 if x, absolute value of x is greater than c. Now this is another nice one. Basically, anything absolute value, if it's greater than c, basically all true real numbers are going to work. So if you get this situation, 3 or 6 are the nice situations where you really don't have to do any work. Once you've set it up and you see that this is the situation I have, then you don't have any actual work to do. Okay. So let's actually look at some examples here of what we have to do. So we want to solve this inequality. So what we have to do first is get the inequality with the absolute value on one side, and then all this other stuff on the other side. So what we'll do is we'll add 4. And so we'll have absolute value of 2 minus x is greater than or equal to a 1. Now, if we can't remember what we have here. Now we have c is greater than 0. Well, absolute value of x is greater than our c. And so absolute value of x is greater than c. C is greater than 0. So we're one of these here positions. We have the or. So we're going to have x is less than a negative c, or x is going to be greater than a positive c. And so what we're going to do is we're going to write this out. We're going to say 2, not x, 2 minus x. 2 minus x is going to be greater than or equal to 1, or 2 minus x is less than or equal to a negative 1. And then we solve those. And because I don't want to go ahead and divide and remember to switch it around, I'm going to add x to both sides first. And so that'll give me 2 greater than or equal to x plus 1. I can subtract my 1. And so 1 is greater than or equal to x. And then we still have or, and then we can say again plus x here. So 2 less than or equal to x minus 1, add 1. And so 3 is less than or equal to x. Okay. Now, I know a lot of people can go straight from there, but there's still a lot of people I know that it's best just to draw the number line. And so I'm going to put 1 here. I'm going to put my 3 here. And x is greater than or equal to 3. So I read it from wherever the x is. So x is greater than or equal to that. So basically I'm going to have this. And x is less than or equal to 1 here. So then I'm going to have this. And then my solution to this is where that is falling. So that's going to go from a negative infinity to a 1. And that's going to be a bracket union. That's going to be a bracket. And then 3 to a positive infinity. Okay. And so that's how you would solve these. And again, this is a lot like if you, I don't know, I've seen this a lot in different classes as far as, even 930, if you've taken that, or 920 even, they do a lot of this absolute value and going both sides and stuff like that. So hopefully this isn't new, going and breaking it, going from the 2x, absolute value of 2x minus 1 is greater than or equal to some number, and then breaking it into the or, and then working down and getting both pieces. So that's one example. All right, so this is one where we have kind of two pieces. Now here we have the and to start with, but we don't really have an and in our set of rules. And so what we're going to do is we're going to work our way through it and kind of split it up on our own. And so we're going to say, well, 2 is less than or equal to absolute value of 4 minus x, and absolute value of 4 minus x is less than 7. Okay, and notice we also have the less than or equal to and strictly less than. So for this first one, what we're going to do is when we do that one, we're going to split it up into the ors, because when you have that greater than, you get or. So we'll have 4 minus x less than or equal to a negative 2, or 4 minus x greater than or equal to 2. And what I did is I just put the value on the other side. And so now we simplify that. And again, what we can do is we can take the x's to the other side, or we can just do the normal way and then start dividing it out or whatever. So if we want to, we can say add x, and at the same time add 2 and add 2. And then over here we can add x, and then we want to subtract 2, subtract 2. And so here we have 4 plus 2 is 6. That's less than or equal to, and then that's x. Or here we have 4 minus 2 is 2, and that's going to be greater than or equal to, and that's going to be x. And so we have this piece solved. So let's go ahead and start drawing our graph of what we have, and then we can put it all together. So we've got x's, so we have a 6 somewhere. We have the 2. And so at the 2, we know it's going to be less than or equal to that. So we're going to go that way. And at the 6, we know it's going to be greater than or equal to that. So we can go that way. Now let's solve this one. Now this one, with a less than, that's going to split it into something that looks more like this. So now we're going to have a negative 7 is less than 4 minus x is less than 7. And so now this one we're going to end up having to go ahead and divide by a negative and change signs at the end, because we really can't do it any other way, but that's okay. So minus 7 minus 4 is going to be minus 11, less than negative x, less than 3. Now we'll divide by negative 1, divide by negative 1, divide by negative 1. So we have to remember to switch these. And so we have 11 is greater than x is greater than, and that was a 3. Okay. So now we know that x is going to be greater than 3, but less than 11. So, all right, so here what we have, oh, negative 3, because we divided. Never mind, sorry. I look in there. So we have, say, negative 3 over here. Let's say we have 11 over here. And it's going to be between those, and it's going to be open circles. All right. And so what we need to do is figure out where these are in overlapping, the and part, the overlapping. Well, it kind of goes from there to there, and there to there. So at negative 3, that's going to be an open parenthesis because it's not closed on this loop. So that's going to be from negative 3. And then here, the 2, it's closed here and it's closed here. So it's going to go to 2, and that's going to be a bracket union. Now it's going to be a bracket here as well, and that's going to be at 6. And here, this goes up to 11, and it's going to be a parenthesis because of that open circle. Okay. And so this one, you had to split apart into 2 things and keep that and in the middle, and then work each way down. And then what happens is this one ends up being another, tripartite that you have to simplify and solve down, but then it's easily solved, and then you can get just that one interval out of it. Okay. Any questions on that one? Now, the nice thing is you could do all these graphically. So we could have gone and said, okay, well, solve this graphically. Well, what you would do is you would solve and draw lines and everything like that. And that's what I'm going to do with this example here, because those are pretty easy to solve by equations. This one gets a little harder by equations. So I'm going to kind of show how we're going to do this graphically instead. And you could do the others graphically as well, just like that. And so what you do is on this case, since we have two absolute values, we're going to have to basically get one absolute value on each side of the inequality. And then we're going to graph each absolute value. And then after that, we can kind of figure out where the inequalities are true based on what we have. So to do this, we're going to have to add the absolute value of 2x plus 1 to both sides. And so we get x minus 3 absolute value is less than absolute value of 2x plus 1. All right, so let's draw this. All right, so what do we know? X minus 3. So that's going to be basically our normal absolute value, just move to the right 3. So if we move it right 3, we're going to be something like that, okay? Now this one, 2x plus 1. So what do we know about that one? Well, if we would do the stretches and all that stuff first, what's going to happen is we're going to end up, if we divide by 2 to kind of get this as a 1, that means we're going to have a half. So we're going to move left a half. And so if that's 1, we're going to start here. And then it's going to have a kind of a shrunk in because it's going to be compressed. And so it's going to be more like this, and then my lines are never going to cross, are they? They will now. All right. So probably the best way though is when we do this, we can plot it by hand, but unless I had graph paper, it'd be kind of hard. So let's go ahead and look and see what it looks like on the calculator. And what I've done, I've already gone ahead and actually plotted it. It looks like, because it looks like these are the equations I just drew. Yeah. Okay. And so we have our equations, and so that's what it's going to look like. Our first one, it's our normal absolute value of x, but it's shifted to the right 3. And this is going to be our other one where we have it kind of compressed together a little bit, and it's only off by the half to the left. Okay. Now what we need is, if we think about it, what we need to do is, it said that the absolute value of x minus 3 was less than the absolute value of the 2x plus 1. Well, this is the x minus 3, and this is the 2x plus 1. So where is the blue one less than the red one? Well, that's going to be basically, from negative infinity all the way up to here, and then from here all the way out here to positive infinity. And so what we need is we need the intersection points there and there. And that's where the calculator comes in handy. So what we're going to do is do our second trace, which is a calculation. And we're going to use our number 5, which is our intersection. And so what it says is pick the first curve. So now we're on the blue one. So we'll say that's the first curve. And the red one's the second curve. And anywhere close to where you're at is good as far as the intersection goes, as long as you're close. And so it says that our intersection is x is equal to 2/3, y is equal to 2 1/3. Okay, so if we remember that, we'll be good to go. So I'm going to write that down. And then what we need is the other intersection. And so we'll do that second trace again, and we want number 5. So now we have to go all the way up here. So let's say that's our first curve, that's our second curve, and our guess, I don't know, maybe is that. Now it says it's -4, 7 is that intersection point, okay? So let's go back. And so this said this was -4, 7, and this one was 2/3, 2 1/3, okay? All right. So with that, now we know that this keeps going out forever. So we're going to go from basically negative infinity up to that -4, and then parenthesis union. Yeah, and then it's only going up to that point. And now we have to come all the way over here, and the only other piece is from there to there. So we have to go from parenthesis 2/3 all the way up to positive infinity. Okay, so basically if we're looking on our graph here, we're going to have, this part is going to be there, And that part is where this piece is less than this piece. And again, we didn't have to do any calculations. We could do it all graphically, which is really nice, especially on ones like this where mathematically this one gets a lot more difficult. And you could do the others that way as well. You could have ended up with some kind of absolute value, and the other one's going to be a line, a y equals, you know, whatever, 3 or 2, and then you'll find out where the points are. And so that's how you would have worked those as well. So when you just have an absolute value equals a number, then that's going to give you just basically some kind of a line, y equals 6, 5, whatever that equals the number over there on that right side is. So that's going to be something you can use as well if you want to do it non hand calculations on the easier ones. All right. So that's a lot of the absolute values. So now what we're going to do is the quadratic. And the quadratic, you know, we've worked with quadratics pretty much all of our lives, you know, something squared. And so what we're going to do is have a quadratic with an inequality symbol in it. And so basically what you have to do is write your inequality as a quadratic function on one side of the inequality and 0 on the other, okay? And then we're going to find all the zeros of the function and place them on a number line with the number 0 above them to kind of indicate that they're zeros. Then we're going to choose some real number, test value is what we call them, in each of the intervals defined in step 2. So, you know, we have whatever your zeros are, those are going to be zeros, and then you're going to have test values on each side of them. So you might have 2 test values only, or you might have 3 or 4 test values. Kind of depends on how many intervals you're going to have. And then you're going to determine the sign of f of x for each value in step 3. And so then you're going to write that sign above or below wherever in the corresponding interval. And then you're going to look and see, you know, based on whatever the inequality was, which piece actually it makes that inequality true with the correct sign. That's going to be your solution to that inequality. Okay. And so I think we might have done a little bit of this solving quadratics, but what you have to do is set the quadratic on one side and 0 on the other. So sometimes they're nice and they set it up for you. You don't have to do anything. Other times you have to subtract things over and get it done. But now what we have to actually do is solve this and get the zeros. Well, that means we have to factor it. Well, to get this one, that's a perfect square, that's a perfect square. So I'm going to assume that this is going to be 4x plus 1 and 4x plus 1. And so that's going to give us 16x squared plus 4 plus 8 and then plus 1. So that looks good. Okay. So now what I'm going to do is solve each of these for 0. Well, they're going to give us the same thing, and it's going to be x is equal to negative 1/4. Okay. So what I have to do then is go over here and on my quote number line, and my negative 1/4, they said that's going to be our 0. Now there's only 2 regions or 2 intervals here, one on each side. And so I'm going to pick some test interval here and some test interval or number here, test value. So what do I want to pick? Well, if I have negative 1/4 here, I'm going to say, well, let's choose 0 here because that's going to be an easy one to plug in. And if I have this one, it really doesn't matter. Maybe I could go to negative 1. I don't know. That might work. So let's plug those values in, negative 1 and 0, into this equation and determine is it positive, negative, or what. So, well, let's do 0 first because that's easy. So that goes to 0, that goes to 0. We get 1. That's positive. Negative 1. Well, negative 1 squared is positive, so we have 16. Then 8 times negative 1 is going to be negative 8. So 16 minus 8 is 8, plus 1 is 9. So that's positive as well. So what do we have here? Do we have just directly all the numbers here? Not really, because we have this 0 here. So that's going to be kind of a break. And so we're going to go from negative infinity to negative 1/4 union negative 1/4 to positive infinity. So this becomes our break, and we can't have a point at the 0, and so this is our solution there. Okay. Now, again, it's nice when you only have 2, then you can easily see it. A lot of times you're going to have 3, maybe test values you're going to have to test. But then what happens usually is it alternates. One's going to be positive, one's going to be negative, one's going to be positive, one's going to be negative. And then based on whatever your inequality is, if you can only use the positives, then you just go and you choose whichever are positive, and you just use the interval that is on. And if you have only negatives, you choose the negative interval instead. But that's how it's going to work. So let's look at another one. Okay, so this one's another nice one. They give everything on the left side. And so we have to solve it. And the key thing is we can go about solving this 2 ways. Well, we can say, okay, well, let's break this down and factor it. Well, I can't seem to factor it nicely, so let's use a quadratic function. Well, remember, since there's no x here, that's a 0x, so that's my b. So 0, whoops. Minus b is going to be, so it's going to be a minus 0 plus or minus the square root of 0 squared minus 4 times 1 times 1 all over 2 times 1. And so that's going to give me, well, 0 drops, so I can leave that. So I have plus or minus. And then here I have 0 minus this, so that's going to be a minus 4 all over 2. Well, that's going to give me plus or minus 2i over 2, which is plus or minus I. Well, on the real number line, i's don't count, and so that means at this point, I say no solution. But if I would actually think about this and went over here and said, well, let's solve this and say subtract 1 here, x squared less than negative 1. When is x squared ever going to be less than a negative? X squared is always going to be positive. So at that point, we could have said no solution as well. And then also the rules, that we looked at before with x and y's, or x and c's and stuff being greater than, less than, things like that. We could have used that as well. But I think either one of these are viable as well, as far as how you solve the question to get the no solution in either case, to show the work and actually get a value out. All right, so the last things basically are going to be a couple of application problems. And so the first one says the profit in dollars made by selling X bottles, and now that they have some weird questions in this book, 100% all natural certified free trade organic Sasquatch tonic is given by P of X equals negative X squared plus 25X minus 100 for X on the interval 0 to 35. How many bottles of tonic must be sold to make a profit of at least $50? Okay. Well, so what we're going to do is we're going to change our thing. And so we're going to say, well, P of X, our profit has to be at least $50. So it's going to be greater than or equal to that. And so we put our equation here. Oop, where'd the 5 go? 100. And so we basically said, okay, well, this here, the profit has to be greater than or equal to 50. And so if we read it from this direction going that way, that's going to be greater than or equal to 50. Now, if we have to solve this for 0 over here to get the inequality in the proper manner, then that's going to be 0 less than or equal to minus x squared plus 25x minus 150. Okay. I'm not going to try to factor that to see what works. So what I'm going to do is I'm just going to say, okay, well, let's say we have, let's just actually use that x minus b, which is going to be minus 25 plus or minus. And then we have b squared, so it's going to be 25 squared minus 4 times a, which is a minus 1, times c, which is now a minus 150, all over, and then we have a 2 times a minus 1 again. And so plugging that into the calculator, now what we're going to get is, looks like we'll have a minus 25 plus or minus 5 over negative 2. After we plug all that into your calculator and take the square root, you just get 5. And so now we have a minus 25 plus 5. So that's going to be minus 20 over minus 2. Or if we take and subtract it, it's going to be a minus 30 over a minus 2. So that's going to be 10 or a 15. And so what does that tell us? Basically, we're going to have to sell between 10 and 15 bottles of tonic, because we knew it was going to be between whatever we found for x's, and we found a 10 and 15, and so between those two, that should give us a profit of at least the $50. All right. All right, so the next one, we're dealing with height and feet of a model rocket. And it's going to be above the ground, t seconds after liftoff is given by that function h of t equals minus 5t squared plus 100t for t in the region 0 to 20. Now, when is the rocket at least 250 feet off the ground? And you need to round your answers to 2 decimal places. So that means we're going to have nasty, probably square roots. We won't be able to just take a nice square root of. So if we want it to be was it at least 250, so we're going to have to say 250 greater than or equal to negative 5t squared plus 100t. Now we solve for this to be 0, so minus 250. So 0 is less than or equal to minus 5t squared plus 100t minus 250. Now here you could do a couple things. I see that there's a common factor of 5 in here, and if I want to make that a positive, I could basically then take the whole thing times a negative 1/5, and that would be the same thing as factoring out the negative 5 and then dividing by it. So then 0 is less than or equal to t squared minus 20t plus 50. Okay. Now I have smaller numbers because I'm going to have to use the quadratic formula again. So x is equal to a minus b, which is going to be a minus 20, plus or minus the square root of. Now I've got minus 20 squared minus 4 times a, which is 1, times c, which is 50, all over 2 times 1. And so then we simplify that one. We get, well, it's going to be a 20 here, plus or minus square root of. Now if we have that, that's 20 squared minus 200. So that's going to be just square root of 200 all over 2. And so now if we actually just are going to take this, it's going to be, you're going to get 1 is 20 plus the square root of 200 over 2. And the other one's going to be 20 minus the square root of 200 over 2. And if we work that out, we're going to get 20 plus 200 divided by 2. So that's going to give us 17 point into 2 decimal places. It's 07. And if we do that one, that's going to be 2.93. And so basically what we're going to have is going to be, the rocket is going to be at least 250 feet and in the region or in the interval. And then we're going to have from 2.93 to 17.07. It's brackets. We have the greater than or less than or equal to, and you could say it, it's between 2.93 seconds and 17.07 seconds. And if you think about it, basically what you've got is your rocket's launching. It's going up. It's going to be in a parabolic form. And so, wherever 250 feet is, it's maybe there. So it's going to go from this point all the way up and over here. And then after that, it's going to drop off to be less than 250. So that first 2.93 seconds, it's going to be under. And then after the 17.07, it's going to be under as well. Okay. All right, so I think that's all I have for today. I've got a couple extra problems. Do you want to do them now, or should I make a second video? Any yeses or no for now or later?
I will make a video on that.
All right. Then I will see you tomorrow. Oh, hey, has anybody done those assessment yet for 1400?
I looked at it. It looks hard. Like, I don't know how I'm supposed to just come up with a problem.
Yeah, it made no sense to me. I was going to ask you about it.
Like, I'm not a math teacher. I don't know how to write a math problem.
Well, what did we just do? We just did one of those.
But like, you wrote it. I didn't have to write it. I just had to solve it.
Well, yeah, but now you just say you just write it and
Why does
say,
the math
okay,
department
a rocket launches, the parabolic path is this, and and you can kind of go from there. I think that's going to be the key. It's not to be thought of as rocket science, ha ha ha. It's just to kind of what does that kind of a function really fit, and that's really what you're trying to do, is to think about how that fits as far as what kind of a problem is it. And it's the parabolic, so you could be throwing a rock up in the air and it comes back down, or you could take a rocket and it launches and then it comes back down, or you shoot a rock up with a slingshot. There's all kinds of different things, and they're all going to be some kind of a parabolic arc. And then what can you get off that parabolic arc? You can get the vertex, and you can get the intercepts, and all kinds of stuff. So I think that's kind of the way you should look at it. Does that make sense?
Yeah, that makes more sense.
Okay. All right, well, I'll see you tomorrow then.
Bye.
Bye.
Could we meet like 2 hours early?